Okay, hi and welcome to lessons 5.9 and 5.10. We're going to do these ones together, parallel and perpendicular lines and their intercepts. So we're going to start off with parallel and perpendicular lines and take a look at how we can recognize those when we're graphing or from an equation. So first we're going to look at parallel lines. We have three different equations that we're going to take a look at in graph. So before I graph, I'm going to write down what my slope is and my y-intercept is for each of them. So that first one, my slope is -1/2, my y-intercept is 5. Now we're just going to assume for our grid here that every line represents 1, so I'm not going to label it with numbers. So my y-intercept is 5, so we're going to go up 1, 2, 3, 4, 5. Remember our success criteria for graphing these lines, always start with your y-intercept. Then we're going to use that and do our slope from it. So our slope is -1/2, so that means we're going to go down 1 and then to the right 2. And we need another dot just to make a good line, so from that dot, down 1 and over 2 again. Right, and then use your ruler. I'm going to attempt to use mine, hopefully it will cooperate, and draw our line. Okay, put some arrows on your line, and then I'm just going to label it with the letter this time because this is A. Okay, so for B, my slope is still -1/2, but my y-intercept is -3. So again, start with your y-intercept, so 1, 2, 3 negatives, and my slope is still down 1 over 2, down 1 over 2. Okay. And draw a line for B. Arrows and a label. Okay, and then one more for C. My slope still -1/2, and my y-intercept this time is 2. So I've got 2 for my y-intercept, and then down 1 over 2 for my slope, down 1 over 2. Get a second dot. Okay, and that's C. Okay, so taking a look at these three lines that we've graphed and their equations, we want to take a look first what relationship exists among the graphs. Well, if we look at all these lines are never going to intersect at any point, so we could say that they are parallel lines. Okay, and then what do we notice about the equations? Well, if we take a look, for all of them, our slope was -1/2, right? So they all have the same slope. Right, in the case here, all of them, our slope was -1/2. Okay, so from this, we can determine that parallel lines all have the same slope. And that's how we can recognize them, whether it's in a graph and we can find the rise over the run and get the slope, or if we're given the equation, we can just take a look at what M is to get to tell that they're parallel lines. The other thing that you should know, parallel lines, the symbol for it is just two parallel lines. Okay, so next we're going to take a look at some perpendicular lines. So same idea, we have some equations, we want to graph the lines. And this time we're going to take a look at two pairs of equations. So A and B we're going to do first. So the slope for A is -2 and the y-intercept is 4. So I'm going to graph that. So start with your y-intercept of 4. And then my slope is -2. Remember that's -2 over 1. So from my dot here, I'm going to go down 2 and then to the right 1. And again, from this dot, down 2 to the right 1. And then draw a line. And remember to always extend your line. So this is A. And I'm going to keep A and B in the same color just so we can distinguish them from C and D. So my slope for B is 1/2 and my y-intercept is -2. Excuse me. So start with my y-intercept of -2 And then this time my slope is a half. So rise up 1, go to the right 2, and then from that dot, rise up 1, go over to the right 2, and draw my line. Okay, so this is B. All right, if we take a look, these kind of cross each other. That makes it look like an X or a T, right? But it looks like it crosses each other in a 90-degree angle, which makes sense because we're talking about perpendicular lines here, so we're hoping that I'm actually graphing some. Okay, so let's try and do this with C and D as well. So my slope for C is 3/4. My y-intercept is -1. So I'm going to start with my y-intercept of -1. My slope is 3/4. So rise up 1, 2, 3, and then run to the right 1, 2, 3, 4. Now I'm not going to have enough room to do that again, so I'm going to use my opposite slope, right? So go back to your original y-intercept of -1, and now this time I'm going to go down 1, 2, 3, and then to the left 1, 2, 3, 4. Right? Remember, you can always do that when graphing your lines. Okay, so this is C. Oops. And then D, if we take a look, my slope is -4/3, and my y-intercept is 2. So let's graph my y-intercept of 2, and then my slope is -4/3. So that means we're going to go down 1, 2, 3, 4, and then to the right 1, 2, 3. And again, from that dot, down 1, 2, 3, 4, and then right 1, 2, 3. Okay, so let's draw this line. Oops. This is D. And if we look at C and D as well, right, they have that kind of 90-degree spot, just like A and B did. So what relationship appears to exist among the graphs? Well, we said they are two sets of perpendicular lines. Now, what relationship appears to exist among the equations? So if we look at A and B and take a look at their slopes, we had -2/1 and a half. And then if we look at C and D, we had 3/4, -4/3. So if we look, both of them had their fractions flipped upside down, and then one was positive and one was negative. We call this negative reciprocals. So our slope for the first one was -1 over the slope of the second one. So they're negative reciprocals. Oops. Okay. Perpendicular lines, we just said perpendicular lines have slopes that are negative reciprocals. And the symbol for perpendicular lines, right, kind of like an upside down T. Okay, so next we want to be able to, state whether the lines are parallel, perpendicular, or neither. So if we take a look at A, we have two equations here. We want both equations in y = mx + b form because we want to compare their slopes, right? That's how we're going to be able to tell whether they're parallel, perpendicular, or neither. This first one's already in y = mx + b form, so we don't have to do anything. Let's just state its slope, which is 3. The second one is almost there. It needs to be divided, have every term divided by 2. So if that's the case and we simplify, we get y = 3x - 3, and our slope is 3. So if we take a look at our slopes, well, they're the same, right? So slopes are same. If the slopes are the same, our rule was that these are parallel lines. Okay, so if we try part B, we've got, again, two sets of equations. So let's rearrange these equations into y = mx + b form. So in this one, we want to move things away from the y. and then divide everything by -2. So we've got 4x minus 3/2. So my slope is 4. In the second one, we can move over the x and divide everything by 4. And we can write 1/4x. That's always allowed if you don't like looking at x over 4. And in this case, my slope is -1/4. So over here we have 4 and -1/4. These are negative reciprocals. So our slopes are negative reciprocals. Therefore, we have perpendicular lines. Okay, so our last example for our parallel and perpendicular lines, we want to be able to write the equations of lines parallel and perpendicular to y = 3x minus 7, and these new lines that we're going to write have to have a y-intercept of 4. So my original equation gave me y = 3x minus 7. Okay, so we know from this one that the slope is 3. So for my parallel line, I know I have to have the same slope, right? So leave the 3. But this new line, they told us in the question it has to have a y-intercept of 4. So we would add 4 to that. For my perpendicular line, we know we should have a negative reciprocal slope. So if the original was 3, we need to flip that fraction, right? Because it was 3/1, so 1/3. And this was positive in the original. Our new one has to be negative. Don't forget your x. And we still want a y-intercept of 4, so plus 4. Okay, so that would give us our parallel and our perpendicular lines to our original. Okay, so next we're going to talk, about some x and y intercepts. So first we want to be able to fill in the table by listing the coordinates for the x and y intercepts. So remember, x and y intercepts are when the line is crossing either the x-axis or the y-axis. So for an x-intercept, it's where it's crossing the x-axis, and in this case, y is always 0. So here we have, again, we're just going to assume that every line represents 1. So in this case, x is 2 and y is 0. For our y-intercept, again, up 2, so our x is 0 now, and y is 2. Okay, so for x-intercept, y always equals 0. For y-intercepts, x equals 0. For graph B, our x-intercept, we're at -1, and our y-intercept, go up 1, 2, 3, we're at 3. For our last one, it's a vertical line. It does have an x-intercept, right? It crosses the x-axis at 2, but at no point is it ever going to cross the y-axis. So the y-intercept does not exist. Okay, so let's take a look here. We're going to do a quick little summary of x and y intercepts. So for x-intercepts, the x-intercept is the place where the line crosses the x-axis. Any point on the x-axis, right, has the form x, 0. At the x-intercept, the y value is always 0. And if we're given an equation, we want to find the x-intercept by substituting y = 0 into the equation and solving for x, right? We know y = 0 for an x-intercept. For a y-intercept, it's going to be the opposite. Any y-intercept is the place where the line crosses the y-axis. Any point on the y-axis has the form 0, y. At the y-intercept, the x value is always 0. And if we're given an equation and asked to find the y-intercept, we want to substitute in x = 0 into that equation and solve for y. So for this next example, they want us to determine x and y intercepts and then graph the line by using them. Then we want to state the slope of the line. So they're giving us this equation, 3x minus 2y equals 12. So remember, for our x-intercept, y equals 0. So I'm going to take my equation and I'm going to plug in y equals 0 in there. So if 2 times 0, we have 0. So 3x just equals 12. And then we're going to divide both sides by 3, so x equals 4. So therefore, my x-intercept is going to be 4, 0. Now we're going to do the same idea for my y-intercept, except this time x equals 0. So now we've got 3 times 0 minus 2y equals 12. So the 3 times 0 is 0. We've got negative 2y equals 12. Divide both sides by negative 2, and y equals negative 6. So this means that our y-intercept is 0, negative 6. So now they want us to graph this line, and we're going to graph it using the x and the y-intercepts. So x-intercept is 4, 0. Again, we're going to assume each line represents 1. So at x is 4, 1, 2, 3, 4, and y is 0. There's my dot. That's my x-intercept. My y-intercept, they said, was 0, negative 6. So go on your y-axis, and now we're going to go down 1, 2, 3, 4, 5, 6 at the very bottom here. Okay? And then we're just going to connect these 2 dots. And yes, in the past we've said 3 dots make a good graph, but if they're asking you to do x and y intercepts, we're only ever going to have 2 dots. Okay, so now I have my line, 3x minus 2y equals 12, and then they want me to also find the slope. So you can do this one of 2 ways. You can use your graph and do the rise and the run, so we can try that, right? So here, if we go up, we can just use our intercepts, right? Up here would be 6, and then to the right here is 2. So this is 3, oh, sorry, not 3, 6, and this is 4. Wow. So my slope would be rise is 6 and my run is 4, but then we need to reduce, so it's 3 over 2. We can also use our equation. If we remember back, the equation would be that slope equals the change in y over the change in x. So we can use our x and y intercepts here. So this would be my x1, y1, and my x2, y2. So y2 would be negative 6 minus 0 here, and then x2 is 0 minus 4. So we've got negative 6 over negative 4, which equals 3 over 2. So either way, we're going to get the same answer. So you could choose in this question which way you want to do it, as long as you show your work either way. So here by solving, or this one by actually drawing your arrows and showing your slope. Okay, so example number 3 wants us to determine the slope of the line whose x-intercept is 3 and y-intercept is 5. So we know we have these 2 points. They gave us 2 points on the line. So the x-intercept is negative 3, and the y-intercept is 5. So now we have to use this nice little equation here. So this would be x1, y1, x2, y2. So 5 minus 0 over 0 minus negative 3. So this is 5 over negative and negative make a positive. So 5 over 3, right? So we could also, and then we were just determining the slope, so the slope equals 5 over 3. If we really wanted to, we could write the equation of the line, because we know the slope and we know the y-intercept. Okay, and last 2 here, we're given an equation and we want to find the x-intercept first. So let's write down our equation. Okay, but remember, if we want x-intercept, we know that y has to equal 0. So I'm going to set y to 0. So now I'm going to have 3x plus 24, but I know I need to move that 24 over. So I'm just going to do that all in the same step. And then I'm going to divide both sides by 3, and x equals negative 8. So therefore, my x-intercept is negative 8, 0. Next, we want to determine the y-intercept of this equation in 2 different ways. So I need to write down my equation first so I can see it. Okay, so in 2 different ways. So the first way we could do just like we did up here, we could have x equals 0. So let's go ahead and try that way. So we've got negative 2y, move this 24 over, make it negative, divide by negative 2, and y is 6. A second way, well, we have this standard form equation. We can convert it into y equals mx plus b form, and that would give us our y-intercept. So we have negative 2y minus 3x minus 24. Divide everything by negative 2. Y equals 3 over 2, x plus 6. Right? That is our y-intercept. So either way, we could figure out the y-intercept. If you're asked in questions, just find the x and y-intercept. I would tend to use this first way because that's what you're looking for, is to do the work. But you could always also check this way too if their question didn't specify. Okay, so that's the end of this lesson. Try the homework for both lessons, right? Be careful, it's 5.9 and 5.10, so try both, and then if you have questions,